We have thus far spoken about quadratic sequences, arithmetic, and geometric sequences. That's where we're at, and what we're going to have a look at today is the sum formula for arithmetic series. And we're going to chat about all of that in a second. Alrighty, but what I want to know from you guys first off, before we get into this, is what are your defining characteristics of each of those sequences? So we've done arithmetic. We have done geometric. Whoops. And we have done quadratic. How do I know that a sequence is arithmetic? How do I know it's geometric? How do I know it's quadratic? So what is its defining characteristic? You can put it on the chat. You are welcome to unmute yourself if you want. You can give me all three. You can give me one of them, but how do we know? Anyone? We do one by one. What's an arithmetic sequence or series? How do I know it's arithmetic? Nice, perseverance. Exactly. The terms in our arithmetic sequence have the same differences. If we want to say constant differences, that's fine as well. As long as you get across the idea that you add the same or subtract the same value each time, we're good. Asya has got all three, which is amazing. So arithmetic, common difference or the same difference. I'm going to start with that. We have a constant difference. What did I say next? Geometric. So Asya said geometric has a common ratio or a constant ratio, whichever you prefer. And we're going to chat about that now in a second. And quadratic has a first and a second difference. And really importantly there with the quadratic, it's got a constant second difference. All right, so this might seem, well, I know this, why are we doing this again? We've already spoken about this, but in this first example that we're about to have a look at, and some of you might have already been trying, we are going to have to solve for an unknown variable, which we have done before in quadratic and arithmetic. And in both instances, I say to you, when you are solving for an unknown, you need to know the characteristics of your sequence that you are working with in order to do that. So if we had an arithmetic sequence and we had an unknown variable in there, we would need to use the fact that the first difference is constant, or we have a constant difference, in order to solve for that unknown variable. Having that knowledge allows us to solve for unknown. So when we get questions like this, and I don't know why it says example 3, I thought I'd just put example. Clearly I was keen on example 3. When we have examples like this, we are able to answer them. All right, so if we have a look at this question, and I'm starting off with this question, guys, because we ended off with geometric on Monday. This is a really nice question to sort of get you into the idea of how we test geometric sequences in exams and in tests. This is definitely the type of question we would ask. I am going to do a lesson on my past paper questions a bit later on in this course, but this is a good sort of idea for you to have of how this will be tested. Right, so we have got x plus 1, x minus 1, 2x minus 5 as the first three terms of our geometric sequence. And the question is asking us to determine the value or values, and that's really important. Whoopsie daisies, let's do this, of x and the possible sequences. Okay, so automatically something in my head should be going, they don't tell us to find a value or values if there's not going to be multiple. And so we should be getting multiple answers for x. Okay, now you guys have said, or we were told there on the group, that the defining characteristic of a geometric, because that's what we're working with, sequence is that constant ratio. All right, so in order for us to find our constant ratio, which we represent with an R, we would take term 2 divided by term 1, and that would be exactly the same as term 3 divided by term 2, which would be the same as term 4 divided by term 3, and I could keep going. As long as you are taking consecutive terms and working out the ratio of them, you are going to find R. And that's exactly what we need to do here. So if we go and have a look at our ratios that we need to use, we would have term 2. So remember, this is term 1, term 2, and term 3. We would take term 2, which is x minus 1, divided by term 1, which is x plus 1, is equal to term 3, which is 2x minus 5, over term 2, which is x minus 1. And the reason I am doing all of this is because I have that constant ratio, okay? The whole purpose of me setting up those fractions and setting up this equation is because I know I'm working with a constant ratio. So now that I have this equation set up, I can go and solve for x. Now, guys, because you've got fractions here with unknowns in your denominator, we need to be careful. And remember, when we're adding or subtracting fractions, we always need to find an LCD. However, because there's one term on either side of my equal sign, a shortcut to not having to work out an LCD times both sides, get rid of the LCD, is just to cross multiply. So we're going to take our denominators and multiply them diagonally with the opposite numerators. That's sort of a shortcut in order to get rid of those fractions. So what we have on the left is x minus 1 times x minus 1. And on the right, x plus 1 times 2x minus 5. And now we've got an equation free of fractions, and I can go and solve for x. So on the left, when I distribute, I've got x squared minus 2x plus 1. And on the right, 2x squared minus 3x minus 5. Now, great tools, if you're not too sure where I get any of the values when I distribute, please just let me know. I sort of just do it all at the same time, but if you're not 100% sure, just let me know. Okay. Now, please remember, whenever you've got squared terms, so whenever you see these x squareds or p squareds or any squared term, we need to think about our quadratic equation. And your quadratic equation has a standard form, and we have spoken about this before, but a standard form of ax squared plus bx plus c is equal to 0. So we always want to try and get our quadratic equation in that standard form for ourselves. And that's what we need to do here. So I'm going to bring all my terms over to the right-hand side. It really doesn't matter which side you choose to go. It makes no difference. We want x squared to be positive. But in doing that, I'm going to end up with x squared. If I bring the minus 2x over, it becomes plus 2x. So minus x minus 6. That's now in the standard form that I want. So I'm happy, and I can now go and solve. Now, guys, remember, you do have the quadratic formula, which is on your formula sheet, which I'll chat about in a second. But this is quite a nice, easy trinomial or a nice, easy quadratic. And so you don't have to use a formula. But obviously, if that's what you're comfortable with, that's what you do. However, this factorized is x minus 3, x plus 2. And so we get our two values for x of 3 or negative 2. So that was the first part of the question. We've solved for our values of x. The second part asked us to determine the possible sequences. Now that's not too tricky. All we need to go and do is we need to go and sub these values of x back into those expressions that I was given originally and find the possible values. So if I sub 3 in, 3 plus 1 is 4. 3 minus 1 is 2. 2 times 3 is 6, minus 5 is 1. So if x was equal to 3, by substituting into these original expressions I was given for each of my terms, I'm able to find my sequence. That is definitely geometric. If you go and work out your constant ratio, it's a half. So you're dividing by 2 each time. So we're happy with that. If I now do exactly the same thing with the negative 2, negative 2 plus 1 is negative 1. Negative 2 minus 1 is negative 3. Negative 2 times 2 is negative 4, minus 5 is negative 9. Again, that's geometric. My constant ratio there is 3, so I'm timesing by 3 each time. And again, it's all found by going back to this original expression for the terms I was given and substituting in. You don't need to show the substitution. You can if you want. It's completely up to you. But you just have to give me the sequence at the end of the day once you found x. So this is just sort of a quick recap of what we did on Monday, the geometric sequences, and a reminder of how we solve these types of questions, because I can guarantee you will be given at some point, whether it's in a test, an exam, in finals, I can guarantee they're going to ask you a question where you're going to have to solve for a variable. Right, I'm going to leave that there. Take your screenshots. If you have any questions, obviously, guys, please ask as I go along. You're welcome to unmute to put it on the chat. So we're going to get into series right now. Okay, so while you're taking screenshots, my first question to you is, what is the difference between a sequence and a series? And that's sort of what I have here. Right, so screenshots, and I'm going to scroll down now. Okay, so what is the difference between a sequence and a series? Who can tell me? You can unmute yourself, or you can put yourself in, you can put your answer in the chat. Anyone able to tell me the difference? Okay, Emmanuel says a series is a sum of numbers. Excellent, and that's what we're going to have a look at today. Nice. Asia, a sequence is the number pattern, and we use a series when we want to find a sum. Awesome. So both of you, amazing, amazing stuff. I'm going to start with the sum because that was sort of the overwhelming thing that we got. Actually, no, let's start with sequence. Just chopping and changing here. So a sequence very basically is your list of values or numbers in your pattern. So if we have a look at the question we just did, the sequence, let's say of the first one, if x was 3, is 4, semicolon 2, semicolon 1, etc., etc. That's just the list of terms in my pattern. Probably would have been better to say that. So let's say list of numbers, terms in the pattern. Exactly as Emmanuel, Asia, and Joy have said, your series is the sum of those terms. So if we now, and that's what we're going to talk about today, your series is the sum of terms in a pattern. So if I took that exact same number pattern that I had, the 4, the 2, the 1, the series would be 4 plus 2 plus 1, etc., etc., etc. So we are now going to, I'm trying my words again. We are now going to have a look at how to work out the sum of an arithmetic series. We're going to do geometric as well, but we're starting off with arithmetic because geometric is quite a cool one to look at. So there's quite a bit more that we need to deal with. All right, so if you want those definitions, take a quick screenshot and let's have a look at the first example to see how we actually find these sums of series. Okay, so if we have a look at our first example, it says quite easy, quite basic. We're not running before we can walk. Determine the sum of the first 12 terms of the arithmetic series 2 plus 5 plus 8 plus etc., etc. So very quickly, just on the notation, you can see here that we've got S in a subscript 12. That basically means the sum of the first 12 terms. In sequences and series notation, that is how we would write it, S12. Okay, and I'm going to write most of my answers and working out like that so we get used to it. The next thing that I want you to be mindful of is the fact that even though we've got these plus signs in between my terms, so 2 plus 5 plus 8, we still can work out our constant difference. And that's what we said is characteristic of a linear sequence. Now, I've said this to you before, I'm going to say it to you again. When you are working with number patterns, the first thing you do is work out the constant first difference, the constant second difference, or the common ratio. Once you have the difference, the second difference, or your common ratio, you are able to answer your questions. If you don't have that, you are going to have to work it out anyways, so rather just do it as the first thing. So if we go and have a look here, hopefully what we can agree on is that each time I'm adding 3 in order to get my next term. So my constant difference here is 3, and we can now go and work from there. So the thing that we need to know is how do we actually find the sum? So for an arithmetic series, your sum formula is S of n, so the sum of n terms is equal to n over 2, open bracket 2a, plus n minus 1 times d. Now you can see this looks quite similar to your Tn formula, which I am actually just going to write down here as well because we're going to use it a bit later, so it's always useful to have. And if we go and have a look, our Tn formula, remember, is Tn is equal to a plus n minus 1 times d. Right, but the formula I want us to focus on right now is the sum formula, because obviously we've been asked to determine the sum of. Now guys, this formula is on your formula sheet, so is the Tn formula, but this is on your formula sheet. And while I said formula sheet again, I've just remembered I wanted to say to you, on the Google Classroom, and remember I spoke about this on Monday, please try and join the Google Classroom, because on the Google Classroom, what I've done is there's a whole bunch of past paper links. I've also gone and taken the formula sheet and broken it down for you. So when I say break it down, I've sort of gone and said this formula you will use for finance. These formulas you will use for trig identities, etc., etc. Because the formula sheet can be a bit overwhelming when you first look at it. If you kind of know where it is that you're looking for different bits of information, it is quite useful. And that is on the Google Classroom. And I will share that joining information a bit later towards the end of the lesson. But just a reminder, please join the Google Classroom. All right, so we're going to use the sum formula again on the formula sheet. Because it's on the formula sheet, grade 12, you don't have to write it down. So you can just go straight into a substitution. If you want to write it down, that's fine, but you don't have to. And so we now want the sum of 12 terms. So the sum of our first 12 terms is equal to 12 divided by 2, open bracket 2 times my first term, which is 2, plus n, which is 12, minus 1 times d, which we've just worked out to be 3. So we literally just take all of the information we worked out and we substitute it into our formula. And then you just put that into your calculator. So I'll give you guys 30 seconds, put that in your calculator and tell me what you get as the sum of these first 12 terms. Nice, guys. Exactly. So the sum of our first 12 terms is 222. So once you have the information you need, chuck it into your formula, put it on your calculator, and off you go. Obviously, these questions will increase in complexity, but if you're just asked a sum question, you need to know what the first term is, what your difference is, and how many terms you're adding. If you've got that information, you are good. All right, so let's have a look at example 2. I'll wait a few seconds in case you want to screenshot this, but let's have a look at example 2 where we're going to find a sum. Actually, no, let's do it at the one where you try by yourselves because I think we got the hang of it. All right, so you can pick, remember, the medium is slightly harder, the easy not as tricky. Pick which one you want to give a try of. I'll write the sum formula again here at the top, just in case you need it. The easy one, you've got the arithmetic series 5 plus 8 plus 11, and I want the sum of the first 20 terms. Whereas the medium one, you've got negative 14, negative 9, negative 4, and I want the sum of the first 100 terms. And there's your sum formula, just in case you don't have a formula sheet with you. And guys, once you are in the Google Classroom, I would even recommend printing out the formula sheet that's there. It's then got the annotations for you. It's also just really useful to have a formula sheet on you when you're doing homework, past papers for practice. It's always nice to just have it just in case. Right, so pick your question. I'm going to stop talking. I'm going to give you some time, and then we'll have a look. And remember, guys, feel free to put your answers on the chat as you go along. It might help someone else. And if you've got questions, again, unmute and ask, or put it on the chat and I'll help you. Obviously, we're told if you're done and you want to do both of them, by all means, go for it. I'm going to give you another minute and then we'll have a look at our answers. Alrighty, guys, let's have a look. Okay, so if you did the easy one, the 5 plus 8 plus 11 to 20 terms, remember, work out what your constant difference is. In this case, it was 3. Tuck it into your formula, 670. Right, if you did the medium one, a similar thing. First work out your first difference. Now guys, this was a slightly harder one because of the fact that you have negative 14, negative 9, negative 4. So even though you start off with negative values, they are getting less and less negative as we move from term to term. So we are adding a value in order to get from one term to the next. And in this case, we were adding 5. Excuse me. So we needed the sum here of the first 100 terms. And so here we have 23,350. Okay, so let's double check. Let's mark. If you guys have questions or you're not too sure where you maybe went wrong, or if you did it differently, or whatever the case is, please ask. Otherwise, we're going to move on to our next example. And remember, guys, trying these things when I give them to you or when we're doing them, it's really useful because it just reinforces and consolidates the method and how we actually answer these questions. Right, so let's have a look at our next example. This one's a little different, and we'll see why now. Consider the following arithmetic series: -3, -5, -7, ... -47. So why this is a bit different is because in this case, I have actually given you where this series ends. So that -47, what I'm telling you here is the last term of your series. Right, now that's quite useful to know and quite useful to see because you're going to see the questions now link to the fact that you know what the last term is. So the first question says, calculate the number of terms in this series. So I essentially want to know if this is the first term, if this is the second, third, etc., 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 what position is this last term? Essentially, how many terms do I have? So now we need to think about this because remember there's two arithmetic formulas. We have T of n as well as S of n. If you have been given no information about the sum of these terms in your series, using the sum formula doesn't make sense. I would have too many unknowns. I don't know what n is. That's what I'm trying to work out. I don't know what the sum is. I would have too many unknowns and I'm overcomplicating things. So we always need to go back to the fact that we do have our Tn formula. And I'm just going to, again, write it down for you. So Tn, again, this is on your formula sheet, is equal to A plus n minus 1d. All right, so this is quite useful for us because we have been given the value of this term. So we know what Tn is. We know what A is. It's my first term. And it's easy for me to work out my difference. And that allows me to then work out what n is, the number of terms. So if we quickly just work out our difference, I can see that each time I'm subtracting 2, so my constant difference is -2. And now I can just substitute into my formula. So Tn is the -47, I know the value. A is -3 plus n minus 1 times that -2. And all we now do is solve for n. Right, now guys, there's lots of different ways you can use your inverse operations here to solve for n. It's really up to you. If we just neaten up the right-hand side and we distribute the -2n, that was a weird situation, and we distribute, then it didn't get any better. We distribute. We have -3 minus 2n plus 2. -3 plus 2 are both constants. And so I've got -2n minus 1. And now I'm going to solve for n. So I'm going to add 1 on both sides, giving me -46 is equal to -2n. And then by dividing both sides by -2, I get n is equal to 23. So what I've now worked out is that there are 23 terms in the sequence, or -47 is the 23rd term. Alrighty, so don't forget your Tn formula. It is sometimes really useful. Even when you have a series, it's still useful. We've now been asked in question B to determine the sum of the series. So remember, what we've now worked out is that we are adding together 23 terms. That is the sum of the whole series. If we've got 23 terms, we're adding 23. Yes, sorry.
Isn't -3 plus 2 -1?
Yes, so here's my -1.
Okay.
And then in my inverse operations, I would add 1 to both sides. And so that gives me the -46. Okay, I hope that makes sense. But yes, absolutely, it definitely is -1. Okay, grade 12s. So I want you to try and work out the sum of the series here. So we know there's 23 terms. Tell me what the sum is. I'll write down the formula for you as well, just in case you need it. Nice one, Nkosi. Remember, grade 12s, whilst you don't have to write down the formula just as the formula, you do need to show your substitution into the formula. That will get you your marks. Nice, Letabo. Nice, Emmanuel. Okay, guys, so your substitution would be 23. Okay, apparently I'm going to write in orange. Over 2, and then your sub would be as follows. And exactly as all of you said, -575. Now just think about it. You are adding a whole bunch of negative terms, which means that your sum should be a relatively big negative value. So if you are stressed about getting a negative sum, just go back to what your series was. If they're all negative values, you should get a negative sum. Righty, so let us just screenshot, and then we'll have a look at another. All right, hope we've got those screenshots. Okay, so again, you're going to try. You've got an easy and you've got a hard one. Find the sum of the arithmetic series 21 plus 23 plus 25 all the way up to 255. And then your medium one, find the sum of the arithmetic series 6, -5, -16 all the way up to -115. Only clue I'm going to give you is, remember, you first need to figure out how many sums are in the series in order to work out the sum. So that's my hint to you. I will give you 5 minutes and let's see how we go. I'm going to start talking so I don't disturb you. And remember, guys, as you're doing this, if you've got questions, just ask. I have given you the hint that you must first find the number of terms in the series before you can find the sum. But just ask if you're struggling. Starting to see some answers. That is great. I'll give you 1 more minute. Okay, guys, let's have a look. All right, so if you did the easy one, the 21, 23, etc., etc., the constant difference was 2. So you needed to obviously first work out the number of terms that you had, as I gave you the hint there. Your number of terms in that series that you were working with was 118. So you worked out the sum of 118 and you got that 16,284. So awesome. Well done, those of you who did it. I did see that answer on the chat. So that's amazing. If you did the medium one, it was the series with the negative value, so we just needed to be mindful of that. Our difference was negative 11. There were only 12 terms in this series, and so the sum of 12 terms, negative 654. And again, saw those answers in the chat coming through, which is amazing. So I'll leave it there in case you want to take a screenshot. And then we're going to move on to sort of the next level of questions, still using our sum formula, but a little bit different to what we've been working with in that we're now going to solve for a variable that is not S sub n. Okay, hoping we've got the screenshots if we need them. Let's have a look. All right, so like I said, this is sort of like next level up. We're now using the equation to solve for something that isn't S of n. So the question is asking me how many terms of the arithmetic series 8, 13, 18, or let's rather say it properly, 8 plus 13 plus 18 plus etc., 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 will add up to 1,700. So what's really important here, guys, is that we have been given the sum. So this is a sum value. We have been given S of n. Now, because of that, we just need to be mindful when we start to substitute into our formula. First thing we always do, though, before we start doing things unnecessarily, is we work out what our constant difference is. In this case, we are adding 5 each time. Okay, so let's think about the information we have. We know what A is, we know what D is, we've just worked it out, and we know what the sum is. We have been asked for how many terms. So in the context of our formula or of our variables, how many terms we are being asked for n. Now, because we've been given the sum, we're going to use our sum formula. T of n here, unfortunately, is no use to us. We haven't been given a term value. We have just been told what the sum is. So we have to use our sum formula. So if I go to my sum formula, I'm going to substitute in everything that I do know, and we will then decide from there what it is we should be solving for. Although we have already said we are solving for n, but you'll see that now clearly when we sub in. So S of n is at 1,700. We don't know n because I don't know how many terms I'm adding together. That was the question. How many terms? We do know what A is because A is our first term. So A is 8 plus n minus 1 times that difference, which we worked out to be 5. So what you need to see here is that what we are actually doing is we are solving for n, right? That is our goal here. If we can solve for n, we can solve for how many terms. Right, now in these types of questions, once again, similar to what I was saying earlier, there are a few different ways you can go and use your inverse operations to solve the equation. My first instinct always is if I can get rid of the fraction, I'm going to get rid of it. So I'm going to multiply both sides by 2 because that automatically rids me of the fraction. And then I've got a much easier situation to deal with. So 1,700 times 2 is 3,400 is equal to, now I just have the n as the coefficient. The 2's gone. I've multiplied it away. 2 times 8 is 16, plus if I distribute this 5n minus 5. Now I can add the like terms in that bracket. So 16 minus 5 is then positive 11. And so I've just neatened up what I'm working with. Now guys, remember, when you are solving an equation, if you're confused about what you should be doing, a good start is make one side equal to 0. And if you've got stuff happening on both sides, so here we've got the 3,400 on one side, and then we've got distribution on the other side, distribute. Okay, we learned in like grade 8, grade 9, we get equations where we will need to distribute before we need to solve, and this is one of them. So I'm going to have to distribute that n into my bracket, and what you're going to see is that we end up with a quadratic. So n times 5n is 5n squared plus 11n. This goes back to what I was talking about earlier, that standard form. We want to get ax squared plus bx plus c is equal to 0. So that's what I'm going to do now. 0 is equal to 5n squared plus 11n minus 3,400, because remember, you've changed its side of the equation. Now, great tools, if you can look at that and you can think of the factors of 3,400 and you can factorize that in your head, you are better than me. I don't think I could do that in my head in a quick situation in terms of like in a test. And so use your quadratic formula. Kirsten, before I carry on, did you have a question? I saw you unmuted yourself and then I was just talking. So I just want to make sure.
No, ma'am, I just wanted to know if you have a quiz today.
Oh, okay. Yes, so guys, we do have a quiz today. I'll explain that. I'm going to finish this example and then I'll chat about the quiz, okay? All right, guys, so we're going to use a quadratic formula. So n is equal to minus b, so minus 11 plus or minus the square root of b squared, so 11 squared minus 4a, which is 5, times c, which is negative 3,400, all divided by 2a, so 2 times 5. And then we just chuck that into our calculator. So I'll give you a second, put that into your calculator and tell me what your two values of n are. Nice. And guys, remember, think about what value n can and cannot be. That's good, girls. I like what I'm seeing so far. I'm going to give you another minute to finish that substitution and get me some answers. Okay, so exactly as we put on the chat, whoops, our two values for n, so we're looking 25 or negative 136 over 5, which is that negative 27 comma whatever. I don't really care what it is because that's not a valid answer. Remember, n can only be a natural number, 1, 2, 3, 4, 5, etc., etc. And so what we worked out is that if I add 25 terms of this arithmetic series, I will end up with the sum of 1,700. All right, guys. So those are the types of questions we can ask you when it comes to your sum or your arithmetic sum. We can ask you for just the basic sum. Here's a series, work out the sum. We can ask you how many terms are in the sequence, and then the sum of those terms that you've just worked out. And we can ask you to work with the sum value that we have given you in order to work out an n value. So there are quite a few types of questions we can ask you here. But like I say, with practice and as you do past papers, you will start to see that it's really those three types, and sort of how you answer them depends on the information that you are given.